Hello class, today I would like to show you how to create a model, part file to be specific, using Solidworks 2019. To the left I have the model in question, to the right you'll see the Solidworks 2019 beginning portion of the screen. To start any type of drawing, whether it's a detail drawing, a model, or an assembly, you do have to first start with File, New. When you click on New, you'll get a choice for what do you want to create, a part, an assembly, or a drawing. You'd want to pick whichever one you want. If you pick part and you hit OK, it'll automatically start you in a part file. What's critical is that you know what type of units of measurement you're in. Are you in inches or are you in millimeters? So you do have to look in the lower right corner, make sure that you're in the correct units of measurement. You are currently in inches, pounds, and seconds, which is correct. That's where you want to be. If you wanted to edit the document units, now's the time to do it. You cannot do it later. You will have much more work to fix your model if you choose to do it later. So make sure your units of measurement are correct up front. That's mission critical. Hit OK. When you're done checking, everything is good. Next thing I would always recommend that you do is turn your planes on, front plane, top plane, right plane, because then you can see where you are in space, as I like to say, in the 3D environment. Otherwise, all you see is a grayish type screen. Nothing's there for you to know what to lock on to. You cannot create a model without using sketches. You cannot create a sketch without using a plane or a surface to apply that sketch on. So that's the reason that you need to know about the front plane, top plane, and right plane. So you cannot draw. I'll keep clicking so you see it. You cannot draw in space. You have to pick a front plane, top plane, or right plane to start any model at all. So in our case, to make life easier, I recommend you turn the planes on. Okay, that way when you click away, you actually see them. Over here is the model, and one of the things people always ask is, well, does it really matter which way I start a drawing? Does it matter which way the part begins? My answer is yes, it does. Why? Because in the middle of your screen, you will see some options here, okay, for what they perceive. They mean the software, but that software is perceiving it based on standards. The standards of where a front view belongs, where a right side view belongs, where the back side view belongs, where the left side view belongs, the top and the bottom. Even a box, there's like this huge, cool geometric box you can use, and there's a presumption of what belongs where. So if you are random in how you model, you actually will have a very random detail drawing. And the biggest problem with a random detail drawing is that companies are not random. They expect you to follow standards of design and engineering, and that includes, I like to call it, respecting the cube. The cube, I'm going to draw right here, that I tell people they need to respect is this guy, where you have the front view, the right view, and the top view. Okay? This cube right here is exactly all the way there. If I put this little arrow here and go into SolidWorks, see that all the way over here, that cube directly correlates with this cube, the isometric cube. Following the simple basic rule will make, 1, your models come out the way they're supposed to, per modeling standards. Number 2, your detail drawing comes out a lot easier, with a lot less work, if you follow this basic rule up front. So please do that. Getting back to the model, here's our model that we want to put into this SolidWorks file over here. So here's this drawing that a client gave us, and now we got to turn it into a 3D model. So the best way to start this particular model can be done a couple of different ways. I'm going to give you one method. Why? Just because. And I know it's not a good answer, because you're going to say, well, I could do it this way, I could do it that way, and the answer is yes, but I'm assuming the person listening to this video doesn't know 5 different ways to make a model. And yes, can I make this model different ways? The answer is, oh yes. And depending on what I'm doing and what my purposes are, I might change the way I build this model. For the sake of today's conversation, and to simplify this video, I'm going to give you one method. And that method, I call it stacking, where I start with the back of the model and work my way to the front of the model. Why? Just to give you a method. Not the only method, not necessarily the most efficient method. It is a method. So it allowed me to teach you some of the commands of SolidWorks. You won't learn all of them in this video, but you'll learn some of them. Specifically, you'll learn how to do circles. You'll know how to extrude. And you'll also be able to learn how to make a rib. This item right here, you'll learn how to make a rib, 4 of them to be precise, on a round surface. Okay, that's the key. That's the biggest thing you're going to learn, is how to make these guys, I made that very scribbly looking, on a round surface. Okay, so back to here. I'm going to start with the base. It's all about the base. We talk about that in class. Click on the front plane and start a new sketch. When you click on the plane, you'll notice with your left mouse button, click on it. You'll notice you get some choices. The choice I would pick is sketch. When you click that, it does rotate, so you can look at it head on. I'm going to start with a circle. Click on the center. Make sure that constraint appears. See that? I'll stop again, just real quick. See the constraint and go out. And then I can go anywhere. I'm going to click out here. I will not change this dimension here, because changing it here does not actually constrain this sketch. Okay, very important that we constrain this sketch. You accidentally click somewhere else, right mouse button and new select. Get away from there. Okay, so there's my sketch. I'm going to go to Smart Dimension. I'm going to pick my object and dimension out here. The number I'm going to select. I'm going to type in my number. To attach my keyboard back to my tablet. So the diameter, the outside diameter of this object is right here. Oops. That's 4 inches. So I'm going to type in 4. Just highlight that, hit the number 4. No. Keyboard not attached. There we go. Hit enter. Okay. Now that's a diameter of 4. I'm going to intentionally go to isometric now so you could see this. You'll notice the color of that circle. Let me X out of here real quick, just so let me delete that. Hang tight. I want to delete this dimension, so I'm going to highlight that and delete it. You'll notice the color is blue. See that? Down here it says underdefined. Down here. See where my mouse is? Right here where it's swirling. It says underdefined. And up here you'll see that it's blue in color. It is subtle. If nothing else, SolidWorks is a very subtle product. I'm going to go out here, type in the number 4. That's already in there. Okay, now that same object is black. I know black and blue are very similar colors. For anyone who's colorblind, I know that can be an issue. But those are the color choices that are defaulted in the software. Can you change them? The answer is yes. That's a different video. I won't spend the time to show you in this one. But you can change the entire color scheme if you wanted to. For now, know that blue is underdefined and black is defined. And now this is fully defined. The things that fully define this particular sketch are the fact that its center is locked into the center of the planes and it has a diameter identified. So it has a constraint of geometry, location, I call it. So the location constraint right here, it's coincident to this intersection, and then a constraint of dimension, which is the 4-inch diameter reference. So it has two constraints attached to it, and that's why it's fully defined. When you're done with this, you can actually switch over to the tab called Features at the top, and then literally just pick Extrude, and go ahead and extrude it. In this case, the extrusion distance is the thickness of the part, and the thickness of the part is 1/2 inch, 0.5. So 0.5. Type that in there. Now, when you look here for different extrude options, just to show you a few things, the default is sketch from plane, which is where it is. That's no problem. The direction can go backwards and forwards. So if you keep flipping this little box right here, which shows you arrows going in 2 different directions, it actually does flip the direction that the extrusion is going in. So for some reason you wanted it to go the other way, you're welcome to do that. You don't have to type in, like some people think, a -0.5 to get it to go the other way. You don't have to do that. You can just go ahead and just type the value in and then flip the direction. This option here is if we had a profile of some kind. We don't, so I mean this is the sketch. And then you do have the option if you wanted to have a tapered type objects. For example, if you were making a punch of some sort and you wanted it to taper in or taper out, this is where you would do that. Drafting in or outward. And then yes, you could actually select a different direction if you were so inclined. So I could have it going 1/2 inch in one direction and 1/4 inch, for example, in the other direction. This object, this particular model doesn't call for it, but I'm just letting you know that that feature is there. I'm going to turn it off because we don't need it. Thin feature, just a word of caution. Thin feature is very, very useful in certain instances, but otherwise, no, not something you want to be doing. A thin feature basically turns this into what I will call a paper bag. It has no thickness to it, so it's got literally no body. It has its place on organic geometry for certain types of windshield designs, things of that nature. It does have a place, but for most modeling, it's not something you're going to use. So I recommend don't do thin feature. It is neat, it looks cool, but it's not, it physically has no, its mass properties are different than a normal object. So if you don't want a solid body, you use a thin feature. But if your object is going to be a real object like this, you don't ever use thin feature. So getting back to this, I'm going to just send this out 1/2 inch in one direction forward, and I'm going to hit OK. Once you have an extrusion, in this case we've got one, they call it a boss extrude. Why do they call it boss? Don't ask, that's what they want to call it. It's a boss or a base extrude. So one can argue it's like embossing, but it's another conversation about language usage. Why do they use this versus some other word? Every product has to call whatever it does something. So in this case, they choose to call it extruded boss / base. There's also revolved boss / base, and that's for future video. Now back to this one. Once you have a base extrude, the next thing you can do is actually build literally on it. So my next shape, first I did this shape, right here. Okay, so I've got that one done. The next shape I want to make is this guy, which is this body right here. Okay? And I'm going to build it right on top on this surface. Okay? Right here on this surface. So notice this dimension here, 2.5. That's this distance. The question is that distance from where this is on the surface or to the back? Technically it's to the back, and the only way you'd know that is when you score your center line. You'll see that it's aligned to the back arc, not the front arc. yes, that is not that easy to see. So no, I don't expect you to be able to see that. Let me delete some of this geometry to make it a little easier for you to see. Got all my scribblies on there. Okay, back to this. This center mark here and here is technically aligned with the back arc. It is not aligned with the front arc. So this 2.5 inch distance is total depth. So if I'm going to start my extrusion from the front face, I do need to account for that difference. I'm not going to extrude it out 2.5 inches. I'm going to extrude it out the difference, 2.5 minus 1/2. Now I'm going to show you, yes, I know how to do math in my head, but I'm going to show you how to do it without doing the math, quote unquote, in your head or pulling out a calculator in a moment. I'm going to go over to sketch. See, I picked this face. You notice this? I picked the face of the object, the face of that existing extrusion. Then I jump over to sketch and I pick circle. Now you'll notice this time it didn't orbit automatically to face you. In order to make this thing face you, you actually have to pick out of this, I call it the center option, set of options, and pick what's called normal to. If you see there, it also shows you can pick Control 8. I did not do Control 8 because you wouldn't have seen me do it. And you would have been like, hey, why did it orbit? Or on your screen, hey, why did it not orbit, but it orbited on the one on the screen? On the video, I mean. So I want you to know how to do that. I can just go and literally pick Control 8. Boom. I'm right there. That's what this is. Normal to. If you keep hitting normal to, it's actually going to flip back and forth to normal to. Normal to is wherever you are sketching. Okay? Again, normal to is wherever you are sketching. So normal to the view you're working on. Think of it that way. It's like an incomplete sentence. So normal to ... to where you are working. In this case, I'm working on this face. So now back to this, I'm going to go ahead and draw a circle. Make sure I pick that center. Go out here somewhere. Go to Smart Dimension. Drop in that dimension. The diameter of 2. Okay, there we go. Now, I'm going to intentionally pick Isometric, which is Control 7. I'm doing it this way so you see what I'm doing. So when I go to Isometric, you see that object is built on the face of the other object. I go over here to Features. See how I spend most of my time between Sketch and Features. You'll notice how I don't exit the command and then do the next step. I don't OK out of it. No, you don't need to. You can just go ahead and jump to the next step. Extrude, I can jump right into it. Now, remember what I said. The total distance is 2.5. The total distance is 2.5. So yeah, I can go do 2.5 minus 0.50. I can do this in my head, yes, and I know so can you. But I'm doing this intentionally. I can do this, and voila, I get my answer. But you know what? I don't need to do any of this work. I don't even need to remember how to do it in my head. All I need to do is replicate my actions here, minus all the scribblies, of course, see, and put them over here. So I can just type in 2.5 minus 0.5. Okay, so voila. If I do that, it will go ahead and extrude it out the difference. Sketch plane, that doesn't change. Blind, I'm not going to send it through the object, I'm going to send it out. And you'll notice how it changed my math equation, 2.5 minus 0.5, and just gave me the answer. See that? That's all it does. So you'll never see the equation in there, you'll only see the outcome. Okay, now, this is also important. See where it says merge results? See that? That's important because you don't want a disjointed model. You have to, if you intend to utilize this in a variety of elements, machining, 3D printing, wherever you're going to send it, merging results is valuable because then it sees both elements as one piece. Now, don't think that that means if I click, oh, then I just won't merge results and it'll see it as two separate parts and this will be now an assembly. No, that's false. Doesn't see that either. Merging results allows these two elements to literally be seen as part of the same part. No, taking this off does not mean now it's two parts and you've started an assembly. That I will be able to discuss that in a separate video. For now, just appreciate the reality that you want to merge your results. Okay? And then we don't need direction 2. We talked about thin feature already. I hit OK. Now I have my extrusion. So now I have my basic geometry. And one of the things that I always teach when I'm in the classroom or online, doesn't matter, is always build up your model with all the elements that make the model first, and then whittle away at it. And the way I phrase it is whittle away at it, a whittle at a time. So I'm going to build everything in my model, the ribs, the base body, this, and then, only then, will I turn around and deal with cuts, like this through hole. I don't deal with the cuts until the end. I don't deal with any of the cuts until the end. Okay? I always start out modeling everything first, and then my secondary operations are removing material. So the beginning of my modeling, I add material. At the end of it, I remove whatever I need to remove for different holes, any type of fillets and chamfers, any type of elements that have to be handled at that time. I always make those operations the last operations. The reason I do that, people will ask, is I have a machining background, so because of that, I tend to think, like, how would I build this? Technically, depending on how technical we want to get, one can argue I would actually start with a large block of metal, and I'd be literally cutting away at it to make any of these features, as you see this feature and this feature. But this, so I don't think purely like a machinist, and literally start with a block of metal. But I do still think in terms of, I've got I want to have my basic shape, and then I want to start cutting into it. So I don't have my basic shape yet, because for me, what I perceive as the basic shapes for this part are having my ribs in, the things I'm scribbling in right now, obviously having my back body in, and having my centerpiece in. Those 3 elements, to me, I know there's 4 ribs, but there are 3 basic elements, are the basics of the model, and then I would think of cutting away elements from this model. So it does help in the design build process to model that way. But to you could do what you want. I'm just trying to give you some ideas of how to create a model with the most amount of efficiency for long-term modifications. Because the other side of my life was custom non-standard products. So I always think about the customer's going to turn around and change something on me. Let me make my model to be the easiest to modify. And I find the easiest way to modify a model is to build up all of its basic geometry first, all of its extrusions and its revolves, and then cut away at it. Okay, so back to trying to put a rib in. Now I bet a bunch of you are saying, well, the rib command's right there. Why don't we just use it? Well, I'm going to basically give away the story right off the bat. You cannot, and by the way, you cannot create a rib on a round surface, whether you want to or not, doesn't matter. Just to prove the point, because of course there's somebody out there saying, of course I can. Here's my basic geometry, yep, see that? Go back to isometric, go back to actually my side view. Let me go to the right side view. Okay, there it is. I'm going to pick this plane, I'm going to create a sketch, and I'm going to go ahead and create the resemblance of a rib. This is kind of what I want it to look like. I'm going to attach my 2 little points. There you go. It's hooked to the front face. It's hooked to that back face right there. So everything looks hunky-dory, peachy keen, and fuzzy-wuzzy. There. Put them all in together at one time. Going to go to features. Going to go to rib. Looks promising, right? The one thing you're going to find out is anytime that you're done with a sketch and you jump over to features, whatever you can potentially use is activated. See that? Whatever you can't use 100% is grayed out. You notice that? So extrude, revolve, sweep, extrude cut, revolve cut, and rib are all activated. Which means supposedly I can use all these with this shape. So let me give rib a try. And pick rib. I'm going to say, oh, yeah, I want it to be how wide? Let's see. 0.38. Now, what do we know about 0.38? Is 0.38 a real number? Yeah, it is, but it's not really 0.38. Anytime you see that 38, like 1-3, things of that nature, appreciate that those are rounded to 2 decimal places. So 0.38 is really 0.375. This is out of your engineering graphics class if you're taking it with us. If you're not taking engineering graphics with us, meaning I teach at Triton College, if you don't take it there, and you're just learning this on your own on the internet, always pay attention to the fact that the number you see in front of you might not be the real number. Whenever you see an oddball number like this, 0.88, appreciate that it's probably 0.875. If you're going to sit there scratching your head saying, why don't you just say 0.875? Well, in the world of engineering graphics, number of decimal places actually denotes tolerance, okay, which directly correlates to cost. So the more decimal places you put on a detail drawing to a customer, the higher the cost for that item because it denotes higher tolerance. So a drawing to 2 decimal places is of a lower tolerance than a drawing to 3 decimal places or 4 decimal places. The more decimal places you see on a drawing, the more expensive that part is. So generally speaking, the drawings that you get to see online and you might model are drawings that come out of probably real parts. I don't know where this one came from, but it was in a book. Forgot from when, but it was passed down to me, so now I have this model. And it does show things to 2 decimal places, but that doesn't mean the numeric value you see is really to 2 decimal places. So please always be cautious about just typing in the number you see, because the number you see, it probably isn't the real value. And in our world, because 3D models go directly to 3D printers or directly to CNC machines, directly coded into final production, the numbers matter. You can't just be random about them. And I know 3 decimal places versus 2 decimal places might not matter too much to you right now, but it does matter a lot in the world of fabrication, and it sure does matter to customers when they're dealing with quality of the part that they're looking to purchase. And if they don't get what they want, they're going to end up sending it back to you. So if you want the right kind of fit, you're going to have to build things in models here to the perfect dimension, because the tolerance is really for the machine, not for 3D CAD. Just please remember that. So getting back to this, so it's 375. I'm going to go ahead and type 0.375. It looks very promising. It looks really good. Let's see, maybe. Let's see. Does it look like, yeah, it looks like it's going to go down to the right. We're going to hit OK. And, gosh darn it, gee willikers. Rebuild error. The resulting rib did not intersect the existing model. Why not? It's right there. You can keep doing this over and over again. It's fine. I promise you it's not going to work. Why? Because it's one round object. See this? This is a round surface, and it's literally you're trying to ask it to solve a relatively complex calculus equation. That's the way I'm going to phrase it. It's not able to do it. Now, I will show you an example where it does work, just to be kind. And just to show you, if hypothetically speaking, I'm going to go ahead and edit this. First, I got to get out of the sketch. So let me get out of the sketch. if this base shape was not round, okay, I'm going to do something a little odd. I'm going to literally go in here, and I forgot what that was called. If you were in class with me, I'd ask, what was that command, guys? It's called normal to. So here it goes. I'm going to go ahead and create a square. I'm a little lazy, so I'm going to actually pick the perimeter. I'm going to go out here. Yeah. Now, you'll notice I picked a square that is larger than the diameter of the object. And now I'm going to go ahead and extrude it. This is an example of where you're going to find me choosing to extrude into the object versus out. Okay, and I'm going to extrude, of all things, instead of blind, I'm going to pick up to next, so it goes to the face here, and I'm going to hit OK. If this was a square block, okay, now let's try it. Okay, I'm going to go ahead and create a sketch. Go ahead and pick there. Pick there. Looking promising. Go ahead to features, go to rib. Oh, well, looks promising. Let me go back to isometric. Okay, change the width again. We're going to make it 0.375. Remember that. Oh, I'm going to hit OK. And, come on, do it. Still get a rebuild there. Gosh darn it, you ogres. Well, maybe I need to just flip it. Yeah, I'll just flip it. Well, flipping it goes out. So let's try that. No, that doesn't matter. Because that's just going out sideways. That's not the solution. Okay, you really do want it to go into the part. So then what's the issue? Well, the front is now square, but what's the back? Back is still a square. So it's not going to work. It's not. Period. So, okay. So one more time, I'm going to go ahead and pick this face. I'm going to go create a new sketch on that face. Pick normal to, and I'm going to make a big square off this center. Go out to this object. Okay, there we go. And now I'm going to go ahead to isometric. Go ahead to extrude. Okay, instead of extruding forward, I'm going to extrude back. And I'm going to extrude to next, or up to surface. And I don't have a surface to extrude to. So I'm going to pick up to, I could pick through all, but that makes no sense. So blind, if I pick, let's see, I'm trying to pick that back, there we go, pick that back face. Come on. Should extrude to that, yeah, it's not picking it. So I'll say up to surface, I'll have to pick the surface. There we go. And then hit OK. So now you got two blocks. Okay, now let's try it. Go ahead and create a sketch. Go into, not isometric, I want to go into normal too. The plane that I selected. Now go ahead and draw a line. Exact same method. Okay, I'm going to jump over to features, go to rib. Okay. Go to isometric. Okay, I'm going to pick the width again, 0.375. Okay, there's the width. And I'm going to hit OK, and bingo! Get exactly what you want. Okay, what was the rule of thumb? You basically have to change the object completely. No, this is not the solution of how to do this. This is not the method to go through. You don't then turn around and say, well, I'll just remove these two crazy ribs, right? I'm sorry, these two crazy bosses, and I'll just delete those. I won't delete any child features like the rib, because the rib came after all this. And then, yeah, it should be fine, no problem. Nah, you see this? You see this nice big error that appears on your screen? Doesn't work like this. You can go ahead and continue error, but it's not happy. Notice the rib is impossible to make on a round object. So please stop trying to use the rib command whenever your objects are round. It doesn't work. So with that in mind, yeah, I get all the nice little errors. And I'm going to keep getting errors until I delete everything that's bad about this thing. So you'll notice that I insist on cleaning it out instead of using this tool where I can just zip through whatever I want to get rid of, so to speak. I'm not getting rid of anything when I do that, by the way. All I'm doing is leaving my garbage, as I like to call it. Don't use this feature right here in order to just put junk below it. You actually do want to clean up your model and not walk out of it with a bunch of errors. Whenever you see this little traffic light symbol, that's what it looks like to me, that means it's time for you to rebuild it. So click on that to rebuild it. Yeah, it's still on there, so something it doesn't like. So I'm going to go ahead and edit. Anytime you want to edit something, it's a little pencil. You see how it's got a little pencil in there? That's how you can edit. So I edit that. I don't do any change to it, but now the rebuild still stayed there. It is what it is. Let's let it be. So if I can't put a rib in using the rib command, I went through all that gymnastics just to show you that you cannot use the rib command. How do you put that rib in? Well, you old school it, as I like to say. You create the shape and you extrude it. So we go back into that view. We're going to go ahead and go normal to. You do still start with that basic geometry of that line, but instead of ending just at that shape, you actually complete the circuit, as I like to call it. Okay, you notice how I'm going there. See how I'm moving my mouse just so you see what I'm doing. When you complete the circuit, then you hit enter when you're done. Come on. There we go. You see how you have a closed shape. Just like in electricity, doesn't work if it's open. An open circuit doesn't work. In our case, an open extrusion, you could end up with different kind of shapes, but in our case we need solid bodies. And so we need a closed shape. So you'll notice how I put it all inside the shape. It does dig into it. Now when I go ahead to features and extrude, now it'll wants to extrude one way, right? Now is an example of where I'd want to change. Instead of a blind extrusion, I'm going to pick the bottom option right here. It says mid-plane. So actually I split my extrusion both ways. So instead of 2.44, I'm going to type in 0.375. See that? And I'm going to hit OK, the little checkbox. Now the top looks good right here, because this shape, see how it's got that little lip in it? See that little lip? That's mathematically correct. It's physically impossible to do it any other way. If I zoom in, if I attempt to zoom into my shape here, you will see that same appearance here. Okay? Now does the back look similar? That's the next question. No, the back looks straight. So it looks like it's sticking out. In fact, it is. See that? The tips are sticking out. Why? Because I horizontally extruded this object on top of a round object. Squares and circles don't, obviously don't fit together perfectly. So the square object is extruding out past the round object. So before I go ahead and fix that, one of the things, I know you might not know me in this video, but my students do. Biggest thing I tell them are a couple of things. One, I'm cheap and I'm lazy. That's the other thing I tell them. So in my case, I want to get this job done quickly, saving the customer money. That's the cheap part, which they'll pay me more for because I can be more efficient. But the other side is I am lazy in the process. And if I can save time and money, time is money, so therefore I've nailed both sets of the equation there. If I can build my model with efficiency. And that's what I really mean about being cheap and lazy. I want to be efficient with how I model this part. So instead of trying to clean off those little corners, first I am actually going to finish adding the other 3 ribs and then cleaning everything up. So the way to do that, to add the other ribs, is to go and do a circular pattern. that's under Features, Circular Pattern. When I click Circular Pattern, now back to the subtleties of SolidWorks. One of the things that you always have to appreciate is whenever you click on a command with SolidWorks, look to the left and see what is highlighted, what's in like a dark blue. Okay, that is what it's expecting you to do. No, it's not the first item on the list. You are correct when you notice that. Well, why did it pick this item? It is not necessarily random, but they chose to program the product in such a manner that they're presuming what you want to do first, not necessarily in the order that you see the different options for that command. So for circular pattern, the first thing it talks about is what's the center of the rotation, the axis, and then which directions are you going into, direction 1 and direction 2, and then it asks you for the features you plan to pattern. No, it's nothing like AutoCAD that goes step by step, lockstep from one thing to the other. This doesn't do that. It does let you hop around, so you do have to pay attention to what's going on in this set of options for this command. The first thing it's asking you to select, even though it's not the first thing on the list, is the item you want to pattern. So when you click on, for example, the Boss Extrude, it clicks on it. The other way to select an item is using the little model tree. You can actually pick the item you want to extrude off the model tree if you know which item it is. Right here is the model tree. Once you've done that, then you have to actually know to do this. You got to click at the top to basically pick the something that's round, the side wall of the object. If it's round, you can pick the side wall. If you don't have anything round, then you actually have to have a real axis, and that means you've got to put one in. So just to show you, I'm going to X out of this real quick. Just to show you how to do that, I'm going to maximize this. The simplest way to do it, some people want to put in an axis, which is right here. I'd say no, I'm too lazy for that. If you go up here and move your mouse so that the word SolidWorks, and you move over, and you see all these drop down options, there's something called View. Under View, you have a series of choices. For the conversation I'm having with you right now, you have a Hide and Show. Okay? Here you see Axis, and then right below it, you see something called Temporary Axis. When you click on that, ironically, what that does, or conveniently, is more the phrase, it actually turns on an axis wherever there is something round. So it finds a center, which is kind of cool. So if you have temporary axis, you can turn that on. If you have an intersection, it'll do it to the intersections as well. And in this case, you've got this perfect center of the two intersecting planes. So it will throw in an axis right there. That's a kind of a nice feature to have. So that way, when you do go back to circular pattern, you have an option there. You've got the object that you want to pattern. When you go back up here to pick the center, you can either pick the center axis, or you can pick the side wall of the round object that you want this pattern to go about. It's up to you. Think of it as a hinge, like a door hinge. It's what you're revolving around, like a revolving door. So if I pick the center, see that? It would be the same. I'm going to move that real quick. It would be the same as me picking this. See how? It doesn't matter which one I pick. Now, instance and spacing, meaning how many do you want? I'm going to be relatively lazy. I'm going to say equal spacing. And I want to have 4. Why? Because that'll take 360 and divide it by 4. So when you see this screen, picture it like a math equation. 360 is the numerator, and the quantity here is the denominator. So 360 divided by 4. It'll space them apart 90. If I pick instant spacing, I actually have to pick what the spacing of each will be. Okay? And then how many? Now, people ask me the question, well, why would I use instant spacing? Why not just use 360? Well, I came out of an industry where we designed product that had to be installed only a certain way, but they happened to be round. So when we didn't want to baffle people, but we were making something called baffles, so there was a little humor in there. In order to make sure someone installed it correctly, we actually had to offset the bolt holes, and one or the whole family would be clocked a certain way so that it was keyed how it would assemble. So that is the reason why instant spacing exists. It does allow you to create essentially a key setting, whereas equal spacing, you're stuck with it. 360 divided by 4. You can't say it's going to be 3. You can't say, well, the last one I want it to be something else. You can't do that. Or I want it to clock a little differently. Can't do that. You have to just go with whatever it gives you. Whereas instant spacing, I could specifically say 92 for angle, and that would make it such that it's a very specific set of positioning that it would be too unique, and it would prevent someone from installing something improperly. So that is the reason why those two options exist, at least for the world I came out of with custom products. So there you go, 360 divided by 4, Boss Extrude. You're going to get 4 items and you hit OK. Once you have them, voila, there they are. So you've got these 4. Now, I told you I was a little cheap and lazy, so I was trying to tell you how I'm going to fix these back spots. Now you're going to tell me, well, you just compounded your problem, because I've got little corners for this guy, and then I've got the little corners on this guy over here. See that? Got those little ribs sticking out, okay? And then I got, obviously, the ones over here sticking out. So on all 4 of them, I've got little elements sticking out. So this is where the machinist in me comes out, and having worked with a lathe on top of it, I think of myself as, oh, I'm just going to put this on a lathe and I'm going to basically wipe out all of these pieces. Well, I can't quite use a lathe the way I would on a real piece of equipment and just selectively shave only here, because it doesn't quite work that way on a 3D product. But what I can do, which is something I cannot do in the real world, is essentially create a circle, which I'm about to do, off the back wall, and basically extrude through and wipe out everything on the outside like a cookie cutter. And that's basically what I'm going to use to get rid of this. So I'm going to put it through a cookie cutter. So I'm going to pick this back wall. I'm going to try to pick this back wall. Hold on. The way that I'm rotating this, by the way, just so you know, is I'm holding my middle wheel. It can get a whittle out of hand, but boom, sorry, have to do it. So I always like to say, if you get lost where you are, just go back to isometric. If you lose your model, hypothetically, double click your middle wheel, or single click actually, my mistake. Okay, I'm going to zoom all the way back out, single click work. It is double click. Yep, it is double click. Double click your middle wheel and you'll zoom back in. So let me do that one more time. All the way out. Double. There we go. Double click. Double click will zoom you back into your part. If you've accidentally zoomed so far away you have no clue where your part is, double click will bring you back. But isometric is only achievable through picking isometric. Okay, so now I'm going to orbit about to the back of this object. I'm going to pick this back side, right mouse button, and create a new sketch right there. Now remember, when you want to create a sketch, you just pick looks like a backwards J. See that right here? If I want to edit a sketch, I pick the backwards J with a little pencil on it. If I ever want to edit a feature, it's also the little object with a pencil on it. Basically, if there's a pencil on the icon, you're editing whatever that icon is. If there's no pencil, you're creating that whatever it is. And so in this case, I'm creating a sketch. If I pick this guy, I'm editing a sketch. Please remember that. I'm going to click on creating a sketch. So on the back, I'm on the back side there. Now, I'm going to actually choose to pick something. I know drawing a circle is fast, but I just want to show you how to do this. Convert entities. Convert entities is a totally awesome tool that allows me to pick the edge of an existing object and basically turn it into a sketch. What's really neat about it is a sketch that's actually constrained to that other object, which means if the diameter of my object ever changes from 4 inches to some other value, this sketch actually locksteps with it and changes dynamically to be the same diameter as that object. So it's a very, very useful tool to use convert entities. Very useful. So I pick convert entities, then I go to features, and then instead of extruding to add material, I'm going to use a new tool called Extrude Cut. When I click on Extrude Cut, obviously the first thing it wants to do is actually wipe out everything inside. So I'm going to say, instead of blind, I'm going to say through all. And you notice, well, if I hit OK right now, yeah, you guessed it, I just wiped out my entire part. Gosh darn gee willikers, boy, that was a bad move. Not a good idea. So it knew that, and it kind of warned me, and I said okay to that. So now I'm going to go back and say, all right, yes, I picked something wrong. So let me go in here. I'm going to pick Extrude Cut, but instead of picking the, just pick through all and just hit OK, I'm going to stop myself and pick this little box right here. See what it says? Flip side to cut. Flip side to cut. We can debate about the language of what that means. You might think it means other side versus the front side. No, it literally means outside versus inside. Visually, annoyingly, if anyone from Solidworks is listening, it would be nice if it worked like it did back in, what was it, 2010, I think? When it visually changed how it looked. Now, for the most part, doesn't have too big of a change. See, if I'm, see what, it's, see that, okay, now it shows gray, yeah. It really doesn't change enough to make me visually see. It doesn't smack me in the face like it used to back a number of generations back of this product. Now you actually have to pay attention to a little tiny arrow. See that little arrow? That tells you, is it going to cut on the inside or is it going to cut on the outside? See that little arrow? Let me put my mouse over it so it highlights itself. Otherwise, it's a relatively subtle little object that doesn't make its presence horribly known. Okay? So it's not blindingly obvious what it's going to do, but that means that it's cutting on the outside. Now when you hit OK, ta-da! Everything is retained. I didn't lose my entire object, but here we go. On the back side, it's all shaved. Those tips are shaved off. Everything is a matching perfect curve. See that? Now, if you guys are going to ask, hey, I shouldn't see that half moon back there, and I shouldn't see this flat part over here, I'm going to remind you all, this is a flat rib. It is not a curved rib. It is not matching the curvature of this object. It is literally a flat rib. Flat. Okay? Why? Because that's what the customer wanted. The only way that you know that is you look at it. Okay? Right over here. It is definitely a flat rib. It is not a curved rib. The last thing that has to be removed is the hole in the middle. Okay, the 0.875. Now, there's more than one method for this. I'm going to show you how to use what's called the hole wizard. Okay, before you ever click on the hole wizard, please pick the face that you want the hole to be drilled through first. Otherwise, it's a pain in the badinsky to use the hole wizard. My opinion, from a user's perspective. It's too many steps to get it done correctly if I pick hole wizard first and then go to the face. So again, when you want to use the hole wizard, Pick the face that you plan to drill the hole through. Then pick Hole Wizard. Okay? Just my advice. Next, as you look at the different options, I would recommend the standard through hole. Okay? Standard hole. ANSI inches is fine. All drill sizes. And look for 0.875. If you know that 0.875 is 7/8, it's easy. If you're not comfortable with decimal fractions conversions, you can always show both units. Okay, see that? Show decimal units. So show decimal values. That way you can actually look for the decimal value and then you'll see the fractional value next to it. Okay? Through all, optional countersink. No, we're not going to put a countersink on anything. Now, something else. Your hole will not appear anywhere until you pick the second tab and go to position. Now, here's the fun part. The default way that this product works is that it automatically jumps into what's called a point. So imagine you're walking around with this little pencil with a literal drill bit attached to your pencil. See that? Wherever you click, and I'll just do it randomly just for fun, it will drill a hole exactly there. Do you see that? So I accidentally picked a spot, and this is like a rabbit, you know, it'll multiply all over. So wherever you click, you will end up with a hole wanting to be dropped wherever. So I'm going to click this spot, and just to be annoying, I'm going to pick, I'll pick this spot just for fun. There you go. If you accidentally do this, don't worry, nothing to worry about. But if you go as far as hitting OK, then you end up literally with 3 wonderful holes drilled into your part. It's a little messy. So what you can do is you can right mouse button and edit the feature. Okay. Go to positions and turn this off by literally clicking on it. Click on the little stars that define the position of the other holes and delete them with your delete key on your keyboard. Just click on it once and hit the delete button on your keyboard. Okay? And then hit OK. That's it. That's all you gotta do. You don't have to delete everything, restart. I've seen people do so many things in the class. No, you don't have to do any of that. Just go ahead and clean that one item. And that's it. Now you basically have your model done. If I go ahead and try to split screen this real quick. There we go. There is your model here. And there's the finished product there. I'll switch to isometric. And that's basically what you're looking for. Okay, in a future video, I will show you how to detail this model as a sectional view and as not a sectional view. Thank you for your time. Have a good day.